This is 7.5, 7.6, part 3. We had just finished example number 3 over here with the angle of elevation, and we found that the height of the wall was 3.8 meters. So again, it's important you do a little sketch first. That would be your first step almost every time, so that you know what triangle you're looking for. And you have to read all the entire question and look at all the numbers given to you. If you don't sketch this out, it's very difficult to understand what they're asking for. So sketch it out first, then draw your triangle, and then make sure you add the important components in there. So let's take a look at example 4. Rocky stood on land 200 meters away from one of the towers on a bridge. He reasoned that he could calculate the height of the tower by measuring the angle at the top of the to the top of the tower and the angle to its base at water level. He measured the angle of elevation to its top as 37 degrees and the angle of depression to its base as 21 degrees. Calculate the height of the tower from its base at water level to the nearest meter. So let's get a, so we have Rocky on land over here. This is Rocky. We have a tower over here. This is our tower. And we know that we have some water over here. And what we know is that Rocky's about 200 meters away from the tower. Now Rocky is looking up at the tower, and while looking up, there's an angle of elevation. And that angle of elevation is 37 degrees. 37 degrees. And Rocky is also looking down to the base of the tower, and the angle of depression there is 21 degrees. And of course, the distance from Rocky to the tower is 200 meters. And as you can see, we have right-angled triangles that are made here, with the tower and the horizontal and the line of sights. So we want to know what the height of the tower is. We want to know this entire height. And what you need to get is that you have two triangles to solve. You can find this height over here and this height over here. That entire height is going to be x plus y. So this is a question where we have both an angle of elevation and an angle of depression. So let's draw out our two triangles. So I'll draw the top triangle first with the angle of elevation. That's a poorly drawn triangle, but there it is. We have 37 degrees. We have side x that we're looking for. We have 200 meters here. And then the other triangle, let me draw it the same way that we see it in our picture. We have 200 meters. You could have drawn it a different orientation, but just make sure everything is in the same relative location. There's a 90-degree angle. Our angle of depression is 21 degrees. And then we have our y that we're looking for over here. And then at the end, once we find x and y, we can add them together to get the total height of the tower. So here, let's look at the angle that we have. We have angle 37. How does x relate to angle 37? Well, let's write out our, so Toa. X is opposite. X is opposite to 37, and we have an adjacent side. So 200 is adjacent to 37, it's right next to 37. So we have, and it's not the hypotenuse, because the hypotenuse is over here across the 90 degrees. So label hypotenuse so you don't make that mistake. So we have adjacent and opposite. So we can use tan. So we know that tan 37 is going to be equal to TOA, so opposite over adjacent. And then we can have tan of 37 is going to be opposite as x over 200. Multiply both sides by 200. And you get 200 tan 37 is equal to x. And so we can put that in our calculator. So 200 times, make sure it's in deg, tan 37. And we get x, we're approximating, and we're rounding to the nearest meter. So I get 150.71, so I'll do that as 151 meters. Now typically I like to round closer to the end. So what I'll do is I'll just leave it non-rounded for now. So I'll do 150.71. I'll leave it to 2 decimal places for now, and I'll round at the end, just so that I'm not rounding too much throughout. The more you round throughout these processes, the farther away you'll be for an answer. So I'll round closer to the end. So there's our first bit, x there. Now we'll do the same thing. We'll find y in this case. So let's look at y. We have 21 degrees. How does y relate? Well, y relates by being the opposite, and 200 is the adjacent. So again, same idea. We have another tan that we can use. So we can do tan 21 is equal to opposite over adjacent. So tan 21 is equal to y over 200. So that means we can multiply both sides by 200. And we get 200 tan 21 is equal to y. So let's do 200 times, make sure it's in deg, tan 21. And we get y is equal to 76.77 meters. So 76.77 meters. And so to find the total height, so this is step one was really our sketch. Step 2 is finding the x value. Step 3 was finding the y value. Step 4 is finding total height. Total height is equal to x plus y, which is equal to 150.71 plus 76.77. And we get approximately 227.48. We'll round to the nearest meters, so 227 meters. If I asked you to round to the nearest tenth, then you would have done, for example, 227.5 meters, depending on what I ask you to round to. So just read carefully where I ask you to round to, and you'll be fine. And then you make your therefore statement. If you have room, you'd make it near the bottom, but here we'll say, therefore, the height of the tower is approximately 227 meters. And so that concludes this sample problem. So throughout this lesson, we saw how to solve entire triangles and also apply our ability to solve triangles using trig ratios into real-world problems that involve angle of elevation, angle of depression, or both of them. You should be able to sketch your problems as you do them to make the triangle that you're trying to solve, and interpret everything carefully so that you do the final work at the end. If you only did steps 1, 2, and 3, and you didn't add the heights up at the end, you didn't really answer the question. You just solved triangles. So the whole point of this is solving to answer a question, to put it in the context in the real world. If we want to know the height of this tower, find the height of that tower. If we want to know, for example, how high the wall is, you need to find the height of this wall, including Lucas's height here, to give you the height of the wall, not just height of part of the wall. So it's important to understand the context and interpret the question properly as well. And the only way to really get that is to practice. It'll seem difficult at first, but then the more of these you do, the easier it'll become. And that's just the way math works.